Emergency fixtures can indeed be on a separate circuit, even if that circuit happens to be the second circuit serving that particular area. The National Electrical Code, or NEC, mandates that emergency lighting operate on a circuit distinct from regular, non-emergency lighting. However, the code does not necessarily dictate that this separate circuit must be exclusively dedicated to emergency lighting alone. Consider the scenario where the emergency fixture is designed as a self-contained unit. This type of fixture incorporates its own internal battery backup system. In this case, it's permissible to wire the emergency fixture to the same circuit that powers the normal lighting. There is a crucial stipulation to this arrangement: the circuit must be protected by a ground fault circuit interrupter, commonly referred to as a GFCI. The role of the GFCI is to monitor the electrical current flowing through the circuit. If it detects a ground fault, which is an unintended path of electrical current to ground, it will rapidly interrupt the circuit. This interruption is vital because a ground fault could compromise the functionality of the emergency light, preventing it from illuminating when needed. On the other hand, if the emergency fixture isn't a self-contained unit and relies on an external, separate battery pack for its emergency power, the wiring requirements change. In this situation, the emergency fixture must be connected to its own dedicated circuit. This separate circuit must also incorporate GFCI protection. Furthermore, the circuit should be solely dedicated to powering the emergency lighting system. This means that no other electrical load should be connected to this particular circuit. Regardless of whether the emergency fixture is self-contained or requires a separate battery pack, a common requirement applies. The emergency lighting circuit must be clearly identified and labeled. This labeling is essential for several reasons. Firstly, it allows electricians and maintenance personnel to quickly identify the circuit as serving emergency lighting. Secondly, it helps prevent accidental disconnection or modification of the circuit during maintenance or repairs. Thirdly, it ensures that the circuit is properly maintained and tested to guarantee its reliability in the event of a power outage. In summary, understanding the NEC requirements for emergency lighting circuits is crucial for ensuring the safety and reliability of emergency lighting systems. By adhering to these guidelines, you can help protect building occupants in the event of a power outage or other emergency situation. It's always recommended to consult with a qualified electrician to ensure that your emergency lighting system complies with all applicable codes and regulations. Understanding the nuances of emergency lighting circuit installations is essential for electrical safety and code compliance. The NEC provides a framework for these installations, but specific interpretations and applications can vary. Here's a more detailed explanation of the key aspects to consider when dealing with emergency lighting circuits. Firstly, dedicated versus non-dedicated circuits. The NEC does not always mandate a completely dedicated circuit solely for emergency lighting. A dedicated circuit means that no other loads, such as receptacles or non-emergency lights, are connected to the same circuit breaker. However, the code allows for emergency lighting to share a circuit with other non-emergency loads under certain conditions. Secondly, self-contained emergency fixtures. These fixtures have an internal battery backup and are designed to provide illumination during a power outage. They can often be connected to a general lighting circuit, provided that the circuit is protected by a GFCI. The GFCI is crucial because it protects the circuit from ground faults, which could disable the emergency light. Thirdly, emergency fixtures with separate battery packs. These fixtures require an external battery pack to function during a power outage. In most cases, these fixtures must be wired to a dedicated circuit that is specifically designated for emergency lighting. This ensures that the emergency lights have a reliable power source and are not affected by other electrical loads. Fourthly, GFCI protection. The use of GFCIs is a critical safety measure for emergency lighting circuits, especially those that also serve other non-emergency loads. A GFCI monitors the current flowing through a circuit and quickly interrupts the power if it detects a ground fault. This helps prevent electrical shocks and fires, and it also protects the emergency lighting system from damage. Fifthly, circuit Identification and labeling. Proper labeling of emergency lighting circuits is essential for maintenance and troubleshooting. The circuit breaker and any associated wiring should be clearly marked as serving emergency lighting. This helps prevent accidental disconnection or modification of the circuit during maintenance or repairs. Sixthly, regular testing and maintenance. Emergency lighting systems should be regularly tested and maintained to ensure that they are functioning properly. This includes testing the battery backup, inspecting the wiring, and verifying that the lights are illuminating correctly. The NEC provides guidelines for testing and maintenance, and it is important to follow these guidelines to ensure the reliability of the system. Seventhly, local codes and regulations. It's important to note that local codes and regulations may have additional requirements for emergency lighting circuits. These requirements may vary depending on the jurisdiction, so it's always a good idea to consult with a qualified electrician or a local building official to ensure compliance. Eighthly, load calculations. When designing an emergency lighting circuit, it's important to perform a load calculation to determine the total amount of power that the circuit will need to supply. This calculation should take into account the wattage of the emergency lights, as well as any other loads that may be connected to the circuit. The circuit breaker and wiring should be sized appropriately to handle the calculated load. Ninthly, wiring methods. The wiring methods used for emergency lighting circuits should comply with the NEC and any applicable local codes. This includes using the correct type of wire, conduit, and fittings. The wiring should be properly installed and protected from damage. Tenthly, emergency power systems. In some cases, emergency lighting is powered by a separate emergency power system, such as a generator or uninterruptible power supply, or UPS. These systems are designed to provide power to essential loads during a power outage. If an emergency power system is used, the emergency lighting circuit should be connected to the system in accordance with the NEC and any applicable local codes. In conclusion, understanding the NEC requirements for emergency lighting circuits is crucial for ensuring the safety and reliability of these systems. By following these guidelines and consulting with a qualified electrician, you can help protect building occupants in the event of a power outage or other emergency situation. Remember to always prioritize safety and code compliance when working with electrical systems. Emergency lighting serves a critical function in ensuring safety during power outages or other emergencies. Understanding the nuances of the NEC regarding emergency lighting circuits is therefore paramount. To elaborate on the previous points, consider these additional factors. Firstly, circuit separation. The intent behind requiring a separate circuit for emergency lighting is to prevent a single point of failure from disabling both normal and emergency lighting. This separation enhances the reliability of the emergency lighting system. Secondly, acceptable non-emergency loads. If the emergency lighting circuit is not dedicated, the NEC may permit certain non-emergency loads to be connected, provided they do not compromise the functionality or reliability of the emergency lighting. Such loads might include exit signs or other critical safety equipment. Thirdly, transfer switches. In buildings with emergency generators or UPS systems, transfer switches automatically switch the emergency lighting circuits to the backup power source during a power outage. The design and installation of these transfer switches must comply with the NEC and other applicable standards. Fourthly, battery backup duration. Emergency lighting systems with battery backups must provide a minimum duration of illumination, typically 90 minutes, as specified by the NEC. Regular testing and maintenance are essential to ensure that the batteries can provide the required duration of power. Fifthly, lighting control systems. Advanced lighting control systems can integrate with emergency lighting systems to automatically activate emergency lights during a power outage. These systems must be designed and installed to comply with the NEC and other applicable standards. Sixthly, emergency lighting types. The NEC recognizes different types of emergency lighting, including exit signs, emergency egress lighting, and standby lighting. Each type of lighting has specific requirements for illumination levels, placement, and circuit design. Seventhly, voltage drop. Voltage drop in emergency lighting circuits must be minimized to ensure that the lights receive adequate power. The NEC provides guidelines for calculating voltage drop and selecting the appropriate wire size. Eighthly, overcurrent protection. Emergency lighting circuits must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from overloads or short circuits. The overcurrent devices must be sized appropriately for the circuit load. Ninthly, accessibility of emergency lighting. Emergency lights must be readily accessible for maintenance and testing. The location of emergency light should be clearly marked, and any obstructions that could block the light should be removed. Tenthly, documentation and record keeping. Proper documentation and record keeping are essential for emergency lighting systems. This includes maintaining records of testing, maintenance, and repairs. The documentation should also include a detailed wiring diagram of the emergency lighting circuits. In summation, emergency lighting circuits are a critical component of building safety. Adhering to the NEC requirements and best practices ensures that these systems function reliably during emergencies, protecting occupants and facilitating safe egress. Always consult with a qualified electrician to ensure compliance with all applicable codes and standards. Expanding on the critical aspects of emergency lighting circuits, particularly in relation to the NEC and practical applications, further clarification is beneficial. Firstly, specific NEC articles. The NEC contains several articles that directly address emergency lighting, including Article 700, which covers emergency systems, and Article 701, which addresses legally required standby systems. These articles provide detailed requirements for the design, installation, and testing of emergency lighting systems. Secondly, emergency power sources. The NEC recognizes various emergency power sources, including generators, batteries, and uninterruptible power supplies, or UPS. Each power source has specific requirements for installation, maintenance, and testing. Generators must be regularly tested under load to ensure that they can provide the required power during an outage. Batteries must be regularly inspected and replaced as needed to maintain their capacity. Thirdly, transfer equipment. Transfer switches are essential for automatically switching between normal and emergency power sources. The NEC requires that transfer switches be tested regularly to ensure that they function properly. The testing should include verifying that the switch can transfer the load quickly and reliably. Fourthly, wiring methods. The NEC specifies acceptable wiring methods for emergency lighting circuits. These methods include using rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. The wiring must be protected from physical damage and installed in accordance with the NEC. Fifthly, lighting control systems. Lighting control systems can be used to automatically activate emergency lights during a power outage. These systems must be designed and installed to comply with the NEC and other applicable standards. The control system should be tested regularly to ensure that it functions properly. Sixthly, illumination levels. The NEC specifies minimum illumination levels for emergency lighting. These levels vary depending on the type of occupancy and the location of the lighting. The illumination levels must be maintained throughout the emergency lighting system. Seventhly, exit signs. Exit signs are a critical component of emergency lighting. The NEC requires that exit signs be illuminated at all times and that they be clearly visible from all directions. The exit signs must be powered by an emergency power source. Eighthly, emergency egress lighting. Emergency egress lighting is designed to provide illumination along the path of egress from a building. The NEC requires that emergency egress lighting be provided in all areas of a building where occupants may need to evacuate during an emergency. Ninthly, testing and maintenance. Emergency lighting systems must be tested regularly to ensure that they function properly. The NEC requires that emergency lighting systems be tested monthly and annually. The testing should include verifying that the lights illuminate properly and that the battery backup provides the required duration of power. Tenthly, documentation and record keeping. Proper documentation and record keeping are essential for emergency lighting systems. This includes maintaining records of testing, maintenance, and repairs. The documentation should also include a detailed wiring diagram of the emergency lighting circuits. In summary, emergency lighting circuits are a critical component of building safety. Adhering to the NEC requirements and best practices ensures that these systems function reliably during emergencies, protecting occupants and facilitating safe egress. Always consult with a qualified electrician to ensure compliance with all applicable codes and standards. To delve even deeper into the specifics of emergency lighting systems and their compliance with the National Electrical Code, or NEC, it's crucial to examine several key elements. Firstly, NEC Article 700. Article 700 of the NEC is dedicated to emergency systems. This article outlines the requirements for power sources, transfer equipment, overcurrent protection, wiring methods, and illumination levels for emergency lighting. Compliance with Article 700 is essential for ensuring the safety and reliability of emergency lighting systems. Secondly, legally required standby systems. NEC Article 701 addresses legally required standby systems, which are systems that are required by law or by a governmental agency to provide power to essential loads during a power outage. Emergency lighting is often included in legally required standby systems. Thirdly, optional standby systems. NEC Article 702 covers optional standby systems, which are systems that are not legally required but are installed to provide power to non-essential loads during a power outage. Emergency lighting is not typically included in optional standby systems. Fourthly, emergency power supply types. The NEC recognizes several types of emergency power supplies, including generators, batteries, and uninterruptible power supplies, or UPS. Each type of power supply has specific requirements for installation, maintenance, and testing. Fifthly, generator requirements. Generators used for emergency power must comply with NEC Article 700.12, which requires that they be capable of providing the required power for the duration of the emergency. The generators must also be tested regularly to ensure that they function properly. Sixthly, battery requirements. Batteries used for emergency power must comply with NEC Article 700.12, which requires that they be capable of providing the required power for at least 90 minutes. The batteries must also be inspected and tested regularly to ensure that they maintain their capacity. Seventhly, UPS requirements. UPS systems used for emergency power must comply with NEC Article 700.12, which requires that they be capable of providing the required power for the duration of the emergency. The UPS systems must also be tested regularly to ensure that they function properly. Eighthly, transfer switch requirements. Transfer switches used to switch between normal and emergency power sources must comply with NEC Article 700.6, which requires that they be automatic and that they be capable of transferring the load correctly and reliably. Ninthly, wiring methods for emergency circuits. The NEC specifies acceptable wiring methods for emergency lighting circuits. These methods include using rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. The wiring must be protected from physical damage and installed in accordance with the NEC. Tenthly, overcurrent protection for emergency circuits. Emergency lighting circuits must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from overloads or short circuits. The overcurrent devices must be sized appropriately for the circuit load and must comply with NEC Article 240. In conclusion, understanding the NEC requirements for emergency lighting circuits is crucial for ensuring the safety and reliability of these systems. By following these guidelines and consulting with a qualified electrician, you can help protect building occupants in the event of a power outage or other emergency situation. Remember to always prioritize safety and code compliance when working with electrical systems. Let's further unpack the complexities of emergency lighting systems, particularly concerning their integration with the National Electrical Code and real-world applications. This detailed explanation will cover, firstly, the scope of Article 700. NEC Article 700 applies to emergency systems intended to supply, distribute, and control electricity for illumination or power, or both, when the normal source of supply fails. These systems are typically installed in places of assembly, healthcare facilities, and other locations where life safety is critical. Secondly, types of emergency systems. Emergency systems can be classified into several types, including emergency lighting, emergency power, and fire pumps. Emergency lighting is designed to provide illumination for safe egress during a power outage. Emergency power is designed to provide power to essential equipment, such as life support systems and fire suppression systems. Fire pumps are designed to provide water pressure for fire suppression. Thirdly, performance requirements. Emergency systems must be designed to provide power within a specified time frame after a power outage. The NEC requires that emergency lighting systems provide power within 10 seconds of a power outage. Emergency power systems must provide power within 60 seconds of a power outage. Fourthly, testing requirements. Emergency systems must be tested regularly to ensure that they function properly. The NEC requires that emergency lighting systems be tested monthly and annually. Emergency power systems must be tested monthly and annually. Fifthly, maintenance requirements. Emergency systems must be maintained regularly to ensure that they function properly. The NEC requires that emergency lighting systems be inspected and maintained annually. Emergency power systems must be inspected and maintained annually. Sixthly, documentation requirements. Emergency systems must be documented properly to ensure that they are installed and maintained correctly. The NEC requires that emergency systems be documented with detailed wiring diagrams and equipment specifications. Seventhly, coordination with other systems. Emergency systems must be coordinated with other building systems, such as fire alarm systems and building automation systems. This coordination is essential to ensure that the emergency systems function properly during an emergency. Eighthly, qualified personnel. Emergency systems must be installed, tested, and maintained by qualified personnel. The NEC requires that qualified personnel be trained and certified in the installation, testing, and maintenance of emergency systems. Ninthly, local codes and regulations. Local codes and regulations may have additional requirements for emergency systems. It is important to consult with local authorities to ensure compliance with all applicable codes and regulations. Tenthly, future trends. The field of emergency systems is constantly evolving. New technologies and regulations are emerging that are changing the way emergency systems are designed, installed, and maintained. It is important to stay up to date on the latest trends in emergency systems to ensure that you are providing the best possible protection for building occupants. In conclusion, emergency lighting circuits are a critical component of building safety. Adhering to the NEC requirements and best practices ensures that these systems function reliably during emergencies, protecting occupants and facilitating safe egress. Always consult with a qualified electrician to ensure compliance with all applicable codes and standards.